This video will actually be a review video. We're not going to learn anything new except for maybe a few additional things, but we're going to review what we learned already. So just as a refresher, we learned a lot of rules. And I actually didn't give you the specific names, but here are all of them. So the one that we'll be using most is the power rule. And then the product rule is for when you have two separate bracketed things and they're multiplied together. Quotient rule is same as product except they're dividing. And the chain rule we learned afterwards when there's functions embedded inside each other. But as you may notice, we omitted one rule we talked about last time. The one which states that the derivative of an entire function is the derivative of each individual term. That rule actually doesn't have a name, so I kind of omitted that, and it's kind of inbuilt to the power rule. So, each individual rule will be put to the test during this little summary and exercise. So, on to the exercises. The first one, over here. This one will make use of the power rule. So, this can be rewritten as x to the power of 2 over 3 plus 4 times x to the power of 3 over 2. Because this is to the power of 2, and this is taking it the cube root, so 2, 3, and vice versa. So now that we have this in this format, we can now apply the power rule. So to do that, basically, we put it down. So f prime x equals, so we put the exponent down, getting us 3. And 2 over 3 minus 1 is negative 1 over 3. Plus 4 times putting it down. And then 3 over 2 minus 1 is just 1 over 2. We can simplify this into 2 over 3 times the cube root of 3x plus 6x, the square root of x. Because the 1 over 2 to the x to the power of 1 over 2 is just the square root. This time that equals 6. This x to the power of negative 1 over 3 is just 1 over the cube root, and then just times 2 over 3. And that will give us our solution. So, our next problem, this one over here. This one will utilize the chain rule, stated over here. The chain rule over here can be seen in here. So this can become our u. So u equals 8x to the power of 3 plus 27. So f u equals the cube root of u, and u equals 8x cubed plus 27. I'm just rewriting that. So now we take the derivative of both of these and multiply them together. So f prime x equals u 1 over 3 and 1 over 3 negative 2 over 3, because this basically just means u to the power of 1 over 3, times, bracketed, times 8x, the derivative of 8x cubed, so 3 times 8 is 24, x, 3 minus 1 is 2. And since this is a constant, and since 27 is a constant, we can just leave it out. And substituting u for this over here, then we will get and we can simplify it if we want to, but that's going to take some time, so we'll just move on to the next question for now. So this question, this will take in both rules of both the chain rule and the product rule, the chain rule and product rule. So we can go back and do it right here. So f prime x is going to be the derivative of this times that. So the derivative of that, so 15 times y squared minus 2 plus the derivative of this times that. So plus 3 over 4. So this is where we use the chain rule because we're taking the derivative of this. So instead of using the long u method we use over here, we're just going to take a shortcut. So we're just going to treat the inner shell as one variable. So, and 3 over 4 minus 1 is negative 1 over 4 times 2y. Basically, the outer shell times the derivative of the inner shell. And that is basically our solution right over there. Except that I actually forgot one last step. This is multiplied by 15x plus 2. And that's our long answer. Again, we can simplify it, but since we want to keep this video short, you can do that in your spare time because simplifying is just some manipulation. I'm going to move this over to make room for this question over here. This question is similar to this, except instead of using the chain rule and the product rule, we're going to be both using the chain rule and the quotient rule this time. Okay, so fx can also be turned into this. Which is that, because the square root of something is just it to the power of 1 over 2. And applying the chain rule, since this is a bit more complicated, I'll take the long route and actually use u. So this will become our u. And then fu would become u to the power of 1 over 2. And u equals 3x plus 8 over 2x plus 5. And the derivative of fx now equals the derivative of this times the derivative of this. This we can't derive right away, so we'll need to use the quotient rule right over here. So, let's do it. So, we get 1 over 2 u negative 1 over 2 and times the derivative of this function over here. And then we keep on repeating it. So we do the quotient rule, which is just negative 1 over 2 u negative 1 over 2 times long 2x plus 5 squared, and then 3, since 3 is the derivative of the top function, times 2x plus 5 minus 2 times 3x plus 8. And that will be our answer once we substitute u for that equation over there, which is just equal to 1 over 2, 3x plus 8, 2x plus 5, negative 1 over 2, and then all of the other stuff over on the right hand side. And again, since simplifying this is quite tedious and it's just some manipulation around, we won't be doing this in this video. So in this video, we have taught you how to actually, some more practice on how to use these rules and theorems, and how to actually use two of them at the same time in one equation. So this has just been some practice on all of the rules. And in the next video, we're going to be learning some applications on derivatives.